Welcome to the deep dive, everyone. We are so glad you're here.
Yeah, thanks for joining us. It's great to be back.
So, our whole mission on this show, for you, the listener, is taking a massive stack of sources and just extracting the essential insights.
Right, doing the heavy lifting so you can get deeply informed without all the overwhelm.
Exactly. And today's mission is a big one. We are exploring the hidden, completely invisible structures of the digital world.
Oh, it's fascinating stuff. Our main source today is the Foundational Text Information Architecture for the Web and Beyond, 4th edition.
Right, the absolute Bible of the industry. But because information architecture, or IA, as we'll probably call it, is so vast, we're doing something a little different today.
Yeah, we're structuring this whole deep dive around core concepts, framing them as clear, high-level questions.
And then we'll just relentlessly hunt for the answers together. But to set the scene for you listening right now, I want you to picture a chaotic, overflowing library.
Oh man, like books just scattered everywhere, stacks on the floor, papers flying, pure information glut.
Yes, exactly. That's our modern reality. But then imagine that chaos slowly shifting, um, organizing itself into a neat, beautifully precise architectural blueprint.
That transition right there, that's what information architecture does. It's the blueprint.
Which brings me to this crazy facts from the text. When you think of the oldest interactive information environment, you probably think of like a 1950s IBM mainframe.
Sure, yeah. Punch cards, spinning magnetic tapes, room-sized computers.
Right, but it's actually not a computer at all. The oldest one is the I Ching, the ancient Chinese oracle.
Oh, wow. Yeah, the authors use that as a foundational metaphor, and it is brilliant.
Right, it uses these 64 distinct hexagram patterns to help people navigate the chaos of change in their lives.
And it's thousands of years old.
Yeah.
But the core human need it addresses is exactly the same today.
Which is what, exactly? Making sense of ambiguity.
Yes, information architecture is essentially this constant, unchanging well that we draw from. The technology around the well changes constantly.
Oh, like going from papyrus to printing presses to desktop computers.
Exactly. And now to smartwatches and spatial computing. The town around the well completely evolves, but the human cognitive need to orient ourselves, that stays exactly the same.
Okay, that makes perfect sense philosophically, but let's dive into our first core question.
Let's hear it.
What exactly is the problem information architecture is trying to solve today? Because if the human need hasn't changed, why is navigating information so insanely hard right now?
It's a great question. And the short answer is that we are going through the rapid dematerialization of information.
Dematerialization. Okay, unpack that for me.
Well, for basically all of human history, information was physically tied to a container. The container and the info were the exact same thing.
Like a book or a stone tablet.
Exactly. The text uses a great music analogy. Think about the Beatles album, Steve Pepper's Lonely Hearts Club Band.
Okay, classic. Vinyl record.
Right. Back in the day, if you wanted to take that music on a road trip, you had to physically take the record off your shelf.
Right, you take the physical object with you.
And when you did that, what happened back at your house? There was a physical gap on the shelf.
Oh, right. A literal empty space where the album used to be.
Exactly. The information was bound by physics. And that gap was actually a huge cognitive cue for your brain.
Wait, really? How so?
It's called cognitive offloading. You didn't have to burn mental energy remembering where the album was because the environment instantly told you it was missing.
Oh, wow. So the physical space was communicating with you. But today, digital bits don't work like that at all.
Not at all. They replicate effortlessly. You download an MP3 to your phone, right?
Yeah, and the original library stays exactly the same. No gaps.
Exactly. A perfect copy goes in your pocket, the original is untouched, and your brain gets absolutely zero environmental cues.
So the information is completely untethered from physical reality. It's everywhere all at once.
Which leads directly to what the authors call contextual proliferation. Because it's untethered, it leaks into every single context of our lives.
Right. Because we used to just search for stuff while sitting at a heavy desk, staring at a massive monitor plugged into a wall.
We were in a very specific, dedicated searching posture. It was intentional.
But now I'm trying to look up complex medical stuff on a tiny 5-inch screen while standing on a crowded, noisy subway.
Or you're barking voice commands at your dashboard AI while driving 70 miles an hour down the highway. The contexts are multiplying.
So how far does that go, this contextual proliferation?
The book brings up this wild case study from South Korea, the Home Plus virtual supermarket.
Wait, a virtual supermarket
Yeah.
on a subway?
Yes. Retailers actually projected these high-definition, life-size photos of grocery store shelves onto the walls of the subway platform.
No way. So you're just waiting for your train, staring at a picture of milk and eggs.
Exactly. And commuters could just use their phones to scan the QR codes on the wall.
How to add items to a digital cart.
Yep. And the groceries would be delivered to their house by the time they got home from work.
That is wild. The whole context of grocery shopping was totally ripped away from the physical grocery store building.
Exactly. The context multiplied.
Mm-hmm.
But, and here's where we run into trouble. When information is everywhere, people get overwhelmed.
Okay, but let me play devil's advocate here for a second.
Go for it.
If the problem is just that we have way too much information everywhere, didn't companies like Google and Yahoo already solve this?
You'd think so, right? With their massive search algorithms.
Yeah. I mean, why isn't a highly optimized search bar enough to fix this feeling of drowning? They index the whole web.
That is a very common trap. A lot of well-funded companies think exactly like that, and it leads to terrible user experiences.
Really? Why doesn't it work?
Because early web solutions focused entirely on indexing and retrieval. That's fine for databases, but it doesn't solve what Richard Sahlwerman called information anxiety.
Information anxiety. That sounds like my daily baseline, honestly.
Right. But finding things isn't just about a robotic arm grabbing a file from a warehouse. It's about coherence.
Coherence. Meaning, does it all make sense together?
Yes. Coherence across all those multiple channels we just talked about. Think about a major news organization like CNN.
Okay, so they have a website, an app, a smartwatch feed.
Exactly. And a truly responsive digital space has to feel like the exact same place, with the same brand authority across all of those.
Right, whether I'm reading a single headline on my watch or watching 3 live video feeds on a desktop monitor, it has to feel like CNN.
Precisely. A search algorithm can find a text file for you, sure. But a search algorithm cannot design a coherent, multi-channel human experience.
Oh, I see. Only information architecture can do that. It's the invisible glue.
Exactly. Which naturally leads us to a really difficult problem.
Okay, hit me. What's the problem?
If information architecture is this invisible structural glue, how do we actually define it?
That is our second core question, Q2. If it's invisible, how do we define it?
In the IA community, this is famously hard. They actually joke about it, calling it DTDT.
DTDT, what does that stand for?
Defining the damn thing.
Huh. I love that. Why is it so damned hard to define?
Because it's dealing with abstract concepts, semantics, language, human psychology. It's not just writing lines of code.
So how does the textbook synthesis it then? There has to be a definition.
There is. They define it as the structural design of shared environments. It blends art and science to support usability, findability, and understanding.
Art and science, that's a really crucial distinction, isn't it? It's not pure engineering.
Right, and it's not just making things look pretty either. It lives right in the middle.
So to visualize that middle ground, the authors use a specific model, right? The information ecology.
Yes, the information ecology. It's usually visualized as a Venn diagram with 3 overlapping circles. You cannot design a structure in a dark room.
It has to survive contact with the real world. So what are the 3 circles?
The first circle is context. This is the reality of the organization building the thing.
So they're business goals. They're funding.
Exactly. Why does the business even exist? What are the internal office politics? What kind of budget constraints are we dealing with?
Right, you can't build a mansion on a shed budget.
Yep.
Okay, what's the second circle?
The second is content, the actual raw material you are organizing.
Meaning the data itself, text, videos, PDFs.
Right. Is it a single 100-word corporate memo or a global database with 1 million hours of video? The structure has to match the volume and format.
Makes sense. And the third circle?
The users, the human beings who actually have to use the system you built.
Right. What are their demographics? What are they trying to do? Are they experts or total novices?
Exactly. You have to understand their information-seeking behaviors. Good information architecture exists strictly in the exact center where context, content, and users overlap.
Okay, here's where it gets really interesting to me. Trying to balance all 3 of those things sounds exactly like planning a massive dinner party.
Oh, I like that. Walk me through that analogy.
Okay, so the users are your dinner guests, and you have to juggle their constantly changing tastes, right?
Right. Some are vegan, some have allergies, some just want a quick drink.
Exactly. Then the content is all the ingredients in your pantry, and they keep multiplying. Some are fresh, some are expiring.
And what's the context?
The context is the house itself, your budget for the party. The fact that you only have 2 ovens, and maybe the roof is actively leaking while you're cooking.
That is a spot-on analogy. And it perfectly illustrates what pioneer Peter Morville calls systems thinking.
Systems thinking, meaning you have to look at the whole party, not just the soup.
Exactly. He advocates moving from boxes to arrows. You have to see how every single element connects to the others.
From boxes to arrows, so mapping the relationships. Like, how does the hot food get from the kitchen to the dining room before it gets cold?
Right. And if half your guests are vegan, do the servers have a clear labeling system so they don't serve the wrong plates in a rush?
The architecture is the system of arrows connecting those boxes.
Exactly. Which means you have to ask a foundational question before you even start building. Are we building a garage or are we building a cathedral?
Oh, I see. Because both are perfectly valid structures, but they have totally different purposes.
Right. But confusing the two halfway through is a total disaster.
Mm.
You don't want to build a utilitarian garage and then suddenly try to install delicate stained glass windows.
The walls won't hold it. The whole structure collapses because the context was wrong.
Precisely.
Mm.
IA forces everyone to agree on what the building actually is before the first brick is laid.
Okay, so let's zoom in on the guests for a minute. The users. This brings up our third core question. Q3. Do people just type in a search box, or is human information seeking more complex?
It is vastly more complex. But for a long time, the digital design industry assumed we just acted like computers.
Right, that too simple model. We just punch in a query and get an answer.
They assumed we queried databases using strict Boolean logic. Input an abstract concept, get a perfect binary output.
But human ideas are incredibly messy. We don't think in SQL commands. We're ambiguous. We change our minds mid-sentence.
Exactly. So the authors break down how we actually look for things into 4 different behavioral modes.
Okay, let's go through them. What's the first one?
First is known item seeking. This is when you're looking for the right thing.
Meaning, I know it exists, and I just need to grab it. Like finding a coworker's phone number.
Or pulling up your specific W-2 tax form from last year. You know exactly what it is. The second mode is exploratory seeking.
Exploratory. So, looking for a few good things rather than one perfect thing?
Yes. Say you want to learn about investing in mutual funds. You aren't looking for one specific mathematical number. You just want to understand the landscape.
Right, you're browsing, you're learning as you go. What's the third?
Third is exhaustive research. This is when you are looking for literally everything.
Oh, like a PhD student doing a literature review. Or a patent lawyer.
Exactly. They cannot afford to miss a single document. Their goal is total extraction. And the fourth mode is refinding.
Refinding. Oh, I do this constantly, looking for something I already found yesterday, but I forgot to bookmark it.
We all do it.
Yeah.
And the reality is, a user might jump between all 4 of those modes in a single 10-minute session.
Oh, totally. I start doing exploratory research on a new laptop. Then I need to known item seek the exact battery life of one model. Then I refind an article I read last week.
Which perfectly illustrates a core concept developed by researcher Marcy Bates. She calls it the berry-picking model.
Berry picking, like foraging in the woods.
Yes. She observed that human beings don't stand still. Formulate one perfect godlike search query and get everything they need in one list.
We wander around, we pick a berry here, a berry there.
Exactly. You pick a bit of information from one source. And that new piece of info actually changes your mental model, which changes your next search query.
So the search evolves as you learn. You browse over here, pick another berry, maybe open a chat window to ask a human a question.
You are seamlessly integrating searching, browsing, and asking. Iteratively.
So for you listening right now, what does this mean for you? It means when you feel completely lost and frustrated on a website, it's usually not your fault.
Not at all. It's often because the designers assumed you'd act like a rigid database, rather than a human wandering through a forest picking berries.
They didn't build paths between the berry bushes. Like, think about a banking website. You go in to check your checking balance. That's known item seeking.
A quick strike in and out.
But then you see a promo for a savings account, so you click it. Now you're in exploratory mode. But the page is full of jargon, so you try to open the help chat.
And if the bank's architecture doesn't let you seamlessly transition between those 3 contexts, you hit a brick wall.
And you just feel stupid, but it's actually an architectural failure.
Exactly. Which naturally leads us to ask, how do we prevent that? How do we build a space that makes sense?
Right, which brings us to question 4. How does a digital space become a place we can actually understand? How do pixels on a screen feel like a room?
This is a concept called placemaking. Andrew Hinton talks about this a lot in his work on understanding context.
Placemaking, meaning creating a sense of location.
Right. Hinton argues that we use the exact same cognitive mechanisms to understand digital screens that we use to understand physical buildings.
We pick up on cues, words, layouts, images, just like we notice things walking through a meadow or into a huge building.
Let's use building architecture as the analogy. How do you know where the entrance to a massive public library is without any words?
Well, the architect uses physical signals, like a huge stone portico, deep shadows around the doorway to draw your eye.
Exactly. Wide, sweeping stairs that force you to elevate yourself. They don't just hang a neon sign saying door. The space itself communicates its purpose.
So how does a web designer build a digital portico? They just have a flat piece of glass.
They use structural organizing principles. The most common is the top-level navigation bar, the links across the very top of a website.
Oh, right, because that establishes the absolute boundaries of the environment.
Exactly. By scanning those top links, your brain instantly understands what kind of place you are in. It develops a typology.
A typology. Like how a banking site inherently feels like a bank, and an online shoe store feels like a store.
Right. But you might wonder, since websites change their visual design all the time, doesn't that ruin the sense of place?
Yeah, companies rebrand, change their colors, update their fonts. Does the building collapse when they do that?
Not if the foundation is strong. This is where Stuart Brand's concept of the shearing layers of change comes in.
Shearing layers, what does that mean?
Brand noted that physical buildings aren't just one thing. They're made of different layers that change at totally different speeds.
Oh, like the furniture changes constantly, but the foundation stays put.
Yes, the stuff inside desks, chairs changes weekly. The space plan drywall, cubicles changes every 10 years. The structural steel changes never.
So mapping that to a digital space, the visual skin is the furniture.
Exactly. The CSS styling, the trendy colors, the big hero images. Marketing can change those every 6 months.
But the semantic structure, the information architecture, that's the load-bearing steel. That stays stable so you don't get lost.
Precisely. Let's look at a concrete example to really test this placemaking idea.
Okay, I love a good concrete example. Let's do it.
The book contrasts the physical Disneyland theme park with the digital Disneyland website.
Oh, that's brilliant. Okay, so the physical park first.
Right. If you go to Disneyland, it is strictly organized by themed lands. Adventureland, Tomorrowland, Fantasyland.
Because the user, the guest, is physically there to be immersed in the fantasy. The architecture supports the experience.
Exactly. It's geographically structured to maintain the illusion. Now, look at the Disneyland website. Is the primary navigation organized by Adventureland and Tomorrowland?
No, it's not. But wait, pushback time. Doesn't that violate the idea of consistency?
How so?
If I'm a loyal Disney fan and I think of the park in terms of those lands, isn't it jarring when the website completely abandons that structure?
It seems like it would be, but trying to mirror the physical park online is the trap of false consistency.
False consistency. Because my intent as a user is completely different when I'm online.
Exactly. If the website forced you to navigate a slow 3D map of Tomorrowland just to book a hotel room, it would be a usability nightmare.
Right. I'm sitting on my couch on a Tuesday night. I don't want a virtual roller coaster. I want to plan a family vacation.
So the website's architecture smartly abandons the lands typology and uses a hospitality typology. Dates, pricing, reservations.
Channel consistency doesn't mean identical replication. It means tailoring the structure to the user's specific needs in that specific channel.
Perfectly said. You strike a balance between what the business wants and what the user actually needs right now.
Okay, so that's the philosophy and the psychology. But let's get our hands dirty. Question 5. What are the actual tangible building blocks of an information architecture?
Getting down to the nuts and bolts, architecture generally flows in two directions, top-down and bottom-up.
Let's start with top-down. What does that look like?
Top-down is centrally defined from above by the designers. It anticipates the user's biggest, most immediate questions.
Like, where am I? What can I do here? How do I call a real human?
Exactly. The book uses the Gustavus Adolphus College website as an example. It has these clear, persistent navigation buckets: academics, admissions, student life.
It's imposing order from the top. If I'm understanding this, top-down is basically like highway signs.
I love that. Let's expand on that.
Okay, so city engineers centrally plan those massive green highway signs. They tell you which exits exist, and they force a strict hierarchy on the geography.
Right, they dictate exactly where the system wants you to go to keep traffic flowing.
Okay, so if that's top-down, what is bottom-up?
Bottom-up architecture is inherent in the content itself.
Yeah.
It bubbles up dynamically from the raw data.
Oh, so sticking with the driving analogy, bottom-up would be like your GPS app. like Waze or Google Maps.
That is a perfect analogy because
Uh-huh.
Waze isn't a static sign. It's reading the dynamic GPS coordinates attached to every single car around you.
And it builds a custom map on the fly based on that microscopic data.
Exactly. Now, to see that in a digital product, look at the iPhone Photos app.
Okay, the native iOS Photos app. How does that use bottom-up IA?
Think about how you search it. You don't use a rigid top-down menu like file year, month, day. That would be awful
No, it just somehow knows where all my pictures were taken.
because the structure bubbles up from the metadata embedded in the photo files themselves, the EDXEF data.
The timestamp and the geographic GPS coordinates attached to the photo.
Yes, because of that bottom-up data, the app can algorithmically group photos into collections based on time and location.
So I can fluidly jump from a map view of Paris straight into a timeline of 2019 without ever touching a drop-down menu.
The architecture emerges from the content itself. It's incredibly powerful.
Okay, so to build these top-down and bottom-up systems, architects rely on what we call the anatomy of IA, right? For main components.
Right, let's categorize them. First, you have organization systems. This is simply how we group things. Subject, chronology, format.
Second is labeling systems. This is how we represent information with language, which is harder than it sounds.
Very hard. Do you use scientific terminology or colloquial layperson terms? If you get it wrong, the user is lost.
Third is navigation systems, how we physically browse, the menus, the breadcrumbs, the global headers.
And finally, search systems, how the user executes queries and how the database indexes and ranks the results.
Okay, let's zoom in on that first component, organization. This brings us to question 6. How do we create order out of all this chaos?
When it comes to organizing content, there are 3 primary structural models that architects use.
3 main ways to build the house. What's number 1?
Number 1 is hierarchies. These are top-down, mutually exclusive parent-child relationships.
Like a family tree or biological classification. Kingdom, phylum, class, order.
Exactly. Human brains absolutely love hierarchies. They are familiar, they reduce cognitive load, and they are almost always the best place to start.
What's the second structure?
Relational databases. These are highly structured grids. They rely heavily on metadata to link tables together.
Oh, like a massive spreadsheet where you can cross-reference an employee's ID with their salary and their department.
Right. Great for uniform, highly structured data. The third one is hypertext.
Hypertext, meaning the loose, free-form web of links that basically built the internet.
Exactly. Author-supplied links that connect completely different concepts based on association rather than strict hierarchy.
Okay, but mentioning hypertext reminds me of a huge historical debate the textbook covers. The rise and fall of folksonomies.
Ah, yes, the Web 2.0 era. People genuinely believed that free-form tagging would replace structured hierarchies.
Right. Sites like theolddelicious.com. The idea was that users would just organically tag content and the crowd would naturally categorize the whole internet.
They called it a folksonomy. The logic was, why hire an expensive information architect when the crowd can just hashtag everything for free?
But it completely failed, didn't it? Time proved the top-down structure is actually vital.
It failed because human language is chaotic. Without a top-down structure, free-form tagging devolves into a nightmare of misspellings, plurals, and dead ends.
So human beings actually need that top-down curation to not feel completely lost in the woods.
We absolutely do. Which brings us to the invisible gears of the internet. The back-end magic that users never, ever see.
I love this part. This is where we talk about metadata, thesauri, and controlled vocabulary.
Yes, this is how architects actually impose order on messy human language.
Okay, give me an example of how this back-end magic works.
Let's use an e-commerce site. Say you go to an online grocery store and you type the slang word brewski into the search bar.
Okay, brewski. Now, logically, the system should crash and show 0 results because no brand officially names their product a brewski.
Exactly. The database only knows the official labels. But a good IA anticipates your messy slang.
How? By using a controlled vocabulary.
Yes, specifically what we call synonym rings. Behind the scenes, the system has a thesaurus running silently.
So when I type brewski, the index catches it.
It catches it, checks a synonym ring, and mathematically equates brewski, suds, pilsner, and ale with the master database term, beer.
So it seamlessly translates my slang into machine logic and just shows me the beer aisle. I don't even know what happened.
Exactly. That is the invisible magic. And this deep metadata tagging supports something even more powerful, faceted classification.
Faceted classification.
You
This
know?
is how we navigate massive sites like Zappos, right?
Yes. Think about trying to find shoes in an inventory of 100,000 items. A strict hierarchy would force you down one rigid path.
Like men's athletic, Nike last size 10, blue. But what if I don't care about the brand?
What if you only want to see blue shoes in size 10 across all brands? Faceted classification lets you do that.
It lets you manipulate multiple variables facets at the exact same time.
You check the box for size 10, the box for blue, and the box for under $50. You're essentially building a custom, highly specific database query on the fly.
But that only works because an architect painstakingly tagged every single shoe with rich metadata beforehand.
Thousands of hours of invisible work, just so the user can click 3 boxes and find their shoes instantly.
Okay, which naturally leads to my final, very pragmatic question. Question 7. How do you actually get information architecture done in the real world?
Because theories are great, but the real world pushes back.
Exactly. Budgets are tight, deadlines are crazy, and office politics ruin everything. How do you go from theory to a finished product?
The book outlines a very rigorous 5-phase program: research, strategy, design, implementation, and administration.
Let's talk about the very first phase, research, because the authors point out a massive hurdle here.
Yes, they call it the paradox of the active user, or more accurately, the active project manager.
Right. Why is research always the very first thing to get cut from the budget?
Because project managers want to show immediate progress to the stakeholders. Sitting around doing ethnographic research doesn't feel like building.
Just start coding. We already know what our customers want.
Exactly, but skipping research means you are building a skyscraper on a foundation of completely unverified assumptions.
So what does the book suggest you do instead?
You have to study the users in the mist. You can't just brainstorm personas in a sterile conference room.
In the mist. Meaning out in their natural, messy habitat. Watching how they actually behave when things go wrong.
Exactly. Okay, so assuming you survive the research phase, you move into design.
Right. And what do information architects actually hand over to the programmers? Because they aren't writing the final code.
They deliver 3 main blueprints: sitemaps, wireframes, and content models.
Let's define those quickly. Sitemaps are
Macro-level diagrams. They show the high-level relationships between all the pages in the system. The bird's eye view.
and wireframes are micro level.
Right. Black and white schematics of an individual page,
Yeah.
showing where the navigation goes, how the content flows, without any graphic design distractions.
But the third one, content models, I think is the most fascinating.
Content modeling is crucial. It's breaking down information into small, interconnected chunks.
The book uses a recipe as an example, right? Walk me through that.
Sure, on a food website, a recipe isn't just a giant paragraph of text. To a database, a recipe is a strict structural model.
It has discrete fields, a title field, a prep time field, an ingredients array.
Exactly. A Boolean value for, is this vegetarian, true or false? Because you break it down into these tiny pieces, the database can do incredible things.
Oh, because if the prep time is an actual integer, a user can search for vegetarian recipes under 30 minutes.
Yes. Deep contextual navigation is only possible if the content is modeled mathematically before it is ever displayed on screen.
Incredible. Okay, but once this perfect system launches, how do you protect it?
From what?
From degrading. I've seen beautiful websites turn into cluttered, chaotic messes after a year because every department just jams their own stuff onto the homepage.
Ah, yes. That is a documented phenomenon called architectural drift, or simply digital entropy,
Right, so how do you fight entropy?
with the final deliverable, the style guide. But it's not a guide about logo colors. It's an architectural rulebook.
It captures the why, the core philosophy behind all the structural decisions you made.
Exactly. So when a senior VP storms in a year later and demands their pet project be put right on the global homepage.
The style guide is the polite, highly documented way to say, no, that braced the cathedral.
Yes, it depersonalizes the argument. It's not you saying no, it's the foundational strategy protecting the user experience.
Wow. This has been an absolutely phenomenal exploration today. We have covered so much ground.
It's a massive topic, but we hit the core pillars.
We dissected how the dematerialization of info causes information anxiety. We learned that we hunt for data like berry pickers, not computers.
We explored how digital spaces use architectural cues to become understandable places, and we looked at the invisible metadata that holds it all together.
It really is a unique discipline. It demands deep psychological empathy combined with rigorous database logic.
It's the ultimate blend of art and science.
So as we wrap up up this deep dive, I want to leave you, the listener, with one final provocative thought to mull over.
Let's hear it.
The authors noted the famous quote that software is eating the world. And as the Internet of Things grows, our physical environment is rapidly becoming a digital information environment.
Oh, absolutely. Every thermostat, doorknob, and street lamp is gaining an IP address and generating metadata.
Exactly. So think about the physical room you are sitting in right now. If you had to design the information architecture for that physical space, how would you label it?
How would someone search for it?
Right. As the physical and digital blend, information architecture won't just be about navigating websites on a flat screen. It will be about how we navigate reality itself.
That is profound.
Just something to think about the next time you can't find your keys and wish your living room had a search bar.
I wish my living room had a search bar every day.
Right. Well, thank you so much for joining us on this deep dive into the source material. Stay curious, everyone.